Okay, we're just going to have a look at part 6D of the January 2011 M2 paper. Read the wording carefully and they give you some information regarding the direction of motion. Well, the direction of motion has to be understood to be the same as the direction of the velocity. They're one and the same thing. Have a think about that for a second. So, what are we given? We're given that the direction of motion at the point B is 45 degrees below the horizontal. So if I draw that down as shown, I've then gone on to create a little right angled triangle, and what you should know is if you've got a right angled triangle, so there's the horizontal component and the vertical component, and one of the angles is 45 degrees, then in fact the triangle must be isosceles. So this is what the situation looks like at the point B with regards to the velocity. In other words, it looks like this. Now, compare the two diagrams, make sure you can see why the horizontal and vertical components must have the same magnitude, and therefore I've said, well, the horizontal magnitude is always the same, with 3 meters per second, i.e. 3I, and therefore the vertical component must in fact be minus 3j as shown. So, at B, the velocity will equal 3I minus 3j. To complete the problem, we're just going to consider the vertical aspect of the motion and use V equals U plus AT. Now, although I haven't done the first 3 parts of this question, I have read through and decided in my mental diagram of the problem that my velocity was positive upwards and also going to the right, which means that my my acceleration will be negative. So V equals U plus AT will look as shown, and now it's just a case of solving that through to give the correct answer of 0.82 seconds.